Okay, now we need to look at the different events. So when you throw a die, we're looking at what can happen. Can we throw a 6 or not a 6? That's what we're looking at. Obviously you can get a 2, a 3 and a 4. That's all including that part there, which is not a 6. So what's the probability of getting a 6 when you throw a die?
1 out of 6.
1 out of 6. So do we all shout out once? Okay, 1 out of 6 probability of getting a 6. The probability that we won't get a 6 is?
5 over 6.
Okay, so that's us filling in the table. Now, what's the probability if I go along this route here? What is this route? Probability of getting a 6 and getting a?
6.
So this is going to be probability of a 6 and the probability of a 6. What does the word and the probability translate in mathematics into? Times. So I'm actually not writing it right on the side. So the first probability of 6 is 1/6. And Umar, the and means times. And the next 6 is still 1/6. Now when you multiply fractions, we do multiply the top and we do multiply the bottom. Unlike in addition of fractions, you do not add the top and add the bottom. Like that. So we have 1 times by 1 is 1. Please don't write down 2. That's a normal answer for the GCSE students in exams. 1 times by 1 is 2. It's not 2, it's 1. No matter how much you want it to be 1. 6 times by 6 is 36. So that's the outcome in that tree, that part of the tree. So I'm considering probability of getting a 6 and another 6, probability of getting 2 6s. Okay? Now I'm going to do the probability of not getting 2 6s. So probability of not getting a 6 and the probability of not getting a 6. That's what dash stands for, not 6. Okay? So now, if we're going on this path, what is going to be? 5 6 times by 5 6. 5 6 times by 5 6. Okay, 5 6 times by 5 6, which will give us 25 over 36. Okay, now, over here we have probability of getting 6 and then not 6. It's an outburst of human madness over there. Probability is not 6 and 6. Okay, I want you to work them out for me, please.
So can I calculate this?
Some of them are done on your sheet. Do one sheet. There. Do you want to need any calculators at the moment? So we're going to calculate stuff. Okay, so Umar, for the second part here, look, you're going this way and that way. So it's this one times by that one for that one. This one here is going to be probability of not getting a 6 and then getting a 6. So this one times by that one because and in there, and means times. And you do it on the sheet for the first question. Here, so 1 6 times by 5 6.
36.
Okay, we got here 5 6 times by 1 6.
36.
Now, what should all of these fractions add up to? What should this one, add this one, and this one add up to? 1. This should add up to 1. That should be 1. That should be 1. That's it. We know that. This is the first call. Okay, they've written as first call and second call. The question. Okay. So this is the probability of the first call, that's probability of the second call. It's got 2 calls coming out of a car park. 2/3 of the cars on British roads are of a foreign manufacturer. Copy and complete this diagram. So all they've given you in the beginning of the question is that this fraction is 2/3. They've given you one fraction for one part of the diagram. Is that enough for the whole diagram? And the answer is yes. Okay, if you know that's 2/3, what must that be? 1/3. And that one is going to be also
1/3.
and 2/3. 1/3 and
2/3.
2/3. Okay. This question has been kept in a simplistic way. Okay. So the probability of each, the first event same as the second event, it doesn't change the second event. Now, so we fill in the table. That's the first thing they've asked us to do. Next thing is they want to know what the probability of the next 2 cars you see being British made. Right. So Idris, probability of British made is going to be this path and that path. So the probability of British and the probability of British. Now, So the probability of this one and that one. As soon as you use the word and, the and becomes a times. So what's the probability of the first British car?
1/3.
Time by. And the second one?
1/3.
And 1/3 time by 1/3 is?
1/9.
1/9. So that's the first part of the question done. The next one says, what's the probability of the next two cars you see not being British made? Well, not being British made is going to be what?
2/3 and 2/3.
That's 2/3 down by 2, isn't it? Okay, now, I'm going to introduce a different type of language now, what they haven't put in there. Okay, what is the probability, and listen carefully to this language now, what's the probability of getting at
The least. British car.
That's my question. Okay, now that the other question was simple. What's the probability of two British? Boom, boom. Probability of two foreign cars? Done. It's easy. The language is easy. It tells you what to do. This one requires interpretation. So if I say to you, work out the probability of getting at least one British car, you have to say, what does it mean first of all? And I always give the students an example of something to eat. Say, for example, somebody's having toast in your house. And the person sitting in your house says, I would like to have at least one toast. So how many toasts do you make? You make one, two, one or more. Okay? So at least one toast means they want one or more and more than one. Okay? So somebody wants at least one toast, that means they want 1, 2, 3, 4, whatever you can make up to. So at least one British car means, so let's get rid of this for the moment. And this one. And let's get rid of this part here. And let's see all the paths that can give us at least one British car. So if I go along here and here, do I get one British car? Okay, choose then. Is that okay? Yeah, because choose more than one is at least one, yeah?
Yeah.
So that's probability of British and probability of British. Now what happens if I go down the British and then I go down the foreign? Do I have at least one there? Yes. Probability of foreign, sorry, British first.
And then foreign.
And foreign. Okay, so at least one British car means you got to have one or more than one. I got one in there. So that's part of the answer. The next one remains. So I've got a French car followed by a
British.
I said French, I mean foreign car. Okay, foreign car, any foreign car, followed by a British car. So probability of a foreign car and the probability of a British car. Now, this is foreign and foreign, it doesn't contain at least one. So we leave that path out. So in this particular question, we've got three answers we've got to deal with. So 1/3 times by 1/3.
1/9.
1/3 times 1/3. Sit next to the please. The second table.
Second one.
Second table, yeah. Okay, the next one's going to be 1/3 times by 2/3.
2/9.
And the next one's going to be 2/3 times by 1/3.
2/9.
Okay, now, what do we do all these nights, please? We already took the time with Nabi. Add them up. This with. So 1/9 add 2/9 add 2/9 will give us 5/9. So that question was a bit more involved because we have to interpret the language. So we have to do at least one British car, which means one or more than one British car. Done? Ladies?
Yeah.
Okay, now, I'm going to give you some time to do some more of these questions over here. So, can we try question number 6, number 8? Can you circle them for me, please? Question number 6, question number 8. And then on the next page, question number 15. And then I'm going to come around and give you the hand on those questions. That's not for me talking down the board, it's time for you to do some questions.